curve, and it might feel on a level that we've done that a ton, and we have. But you need to differentiate between two types of calculus questions, okay? So, if I ask you, hey, what's the difference between this question, here's an integral, evaluate, and the question, find the area between the x-axis and that curve on 0 to 3, I said it feels like they're the same, but they're slightly different, okay? This definitely is, I guess graphically, is the same as this. It's a parabola with zeros at 0 and 2. Do you agree with me so far? Okay. Now, if I were to shade the region this is talking about, then remember, at its most basic level, this is the sum of rectangles. I know it's been a long time. We've gone so far past that you tend to forget that. But this is base dx times heights. And so it's the sum of infinitely many, infinitely thin rectangles. Now, because I have done nothing to make these y values negative, then the area here, this will be a negative area, and this will be positive area. So if I just plowed ahead and did this, then I would say this is 1/2 or 1/3 x cubed minus x squared from 0 to 3. And that would be something like 1/3 of 27 minus 9. Or 0. You see what I'm saying? Unless I made a mistake. Did I make a mistake? I'm in a little bit of a math slump. My confidence is shaking. Am I good? Okay. All right. Now, it feels like that's kind of weird on the surface because it's saying the area is 0, but it's really, this represents the net area. It's the combination of negative area and positive area. And the fact that this was negative is sometimes okay. For example, if I wanted to talk about how something moved, then I want to take into account it moved backwards and forwards. And so I would allow that negative to happen so that I could see, hey, the net displacement was 0. Okay? However, if the question is phrased this way, the area between the x-axis, then area is kind of code word for area should be positive. And the idea then is not net area, where you're allowing negatives, but total area. No negatives. That's the distinction between the two. And again, they're very similar in that they're talking area, but it's net area versus total area. You with me? Okay. Well then, if I were going to do this question, when I say if the area question, that's the second one now. The integral's in the background. I already know that's 0. But if I asked you the area question and you're allowed to use a calculator, then I want to make sure that all parts are made positive. What math operation do I do that with? Absolute value. Now, if you use your calculator, then it would be something like 0 to 3 of the absolute value of the curve. And that takes away the negative height component to this, makes all height components positive, and therefore total area versus net area. It's going to make, in the calculator kind of graphically, we're looking at the graph now becoming more like this. All y values are positive, so total area is going to be found, not net. So if you would, throw that in your calculator, please. You'll need your calculator today in pieces. Make sure you can find the absolute value component to your calculator. In the Inspire, I think it's in that little catalog menu above or next to the 9. Is that right? I'm not very good with Inspire. I know on the 84 it's math num. Let me try this. If you need a calculator, feel free to grab one. So I remind you, a definite integral, the shortcut is shift plus to get a definite integral, and poof, that's not what I want to be. Never mind. I'm going to go to my home screen and then do shift plus. From 0 to 3, if I'm not mistaken. And the absolute value is in here. We? Or not. Yeah, there it is. Boom. Hi, there you are. Yeah, all right. Cool. So then, x squared minus, I can't remember what it was, 2x? 2x with respect to x. And I got 2 and 2/3. We? Way. Okay. 2 and 2/3. And boom. We're good. They're 8/3. Okay. Now, had you been asked to do this without a calculator, then obviously you're going to have a little more work cut out for you here. So how do I make or deal with the negative area? I cannot just throw an integral at it, okay? Because I think we already established if I throw one integral at this, I'll get net area and I get 0, and that's not what the answer should be. So what's a way of dealing with the negative? You can see you'll need to split it up, absolutely. Split into pieces above and below. So it'll be 2 integrals. Okay, what about the pieces below? How do I make them positive? You just negate them. You throw a negative in front of that. So you negate regions below. Okay, I know I'm going to get a negative area out of that, so I'm going to take I got a piece of donut stuck in my throat. Regions below, you're going to negate the area below. So the first integral will be the opposite of the area from where to where? 0 to 2. Now notice then, I'm not doing absolute value here. That's for a calculator. And then what about the area from 2 to 3? Negate it or just leave it? Leave it. It's already positive, so just call it add that area. Okay, you could do that. You could also bring in the negative and switch these. You might see 0 to 2 of x minus x squared. That would be the same, wouldn't you say? Okay, so if I were to then integrate, what is the antiderivative of x squared minus x? 1/3 x cubed minus 1/2 x squared from 0 to 2. The good news is the antiderivative is the same in both cases. 1/3 x cubed minus 1/2 x squared from 2 to 3. The reason we have to do them separately is one needs to be negated before we total. So if I find this first one, maybe 8/3 minus 2 minus 0. And then this would be something like 27/3 minus 9/2. That quantity, take away 8/3 minus 4/2. Stop if you disagree.
2x. X squared plus 2x.
Oh, shoot. Huh? Oh, man, you're telling me that now? Jeez Louise, you could have told me that 10 minutes ago. Dude. Ay. What do you, the rest of you just, oh, well, I'm going to write it. Oh, there we go. Hey. What the freak the heck? Wake up, man. Jeez Louise. Way to critically think. One person, who said that? Who told me? Ethan? You could skip one of tonight's homework for at least telling me late. Better than nothing. 2x. The rest of you, geez Louise. 2x. So x squared. 2 to 3. All right. So this then, I apologize, is something more like 8/3 minus 4 minus 0, which will be negated. Plus 27/3 minus 9 minus 8/3 minus 4. Wait. Okay, so I'm going to just finish this. What is 8/3 minus 4? 8/3 minus 12/3, or negative 4/3, then made positive. In other words, I got a negative area in that first part, but I made it positive. So that little piece area was 4/3. Cool. Back here, I got 27/3 minus 8/3, which is 19/3. And negative 9 plus 4 is negative 5. This doesn't feel like it's coming out to be 8/3 to me, but we'll see. Okay, so I get 4/3 plus 19/3 minus 5. What's 4/3 plus 19/3? 23/3 minus 15/3 is 8/3. Sure enough, it worked. Okay. So you can see you have a little bit more work to do if you have a no calculator, but it's going to be no calculator quite frequently. All right. So that's the idea. Now let's say we do one all the way through with a calculator, and then without a calculator. So if I asked you to find the area enclosed by this baby in the x-axis and show appropriate work, then would you try that on your own? And let's see how we do. 1, negative 5, 1. The fact that it's calculator doesn't excuse you from showing the setup. What's the setup you're going to use? How do you find area? Actually, graph it first so we can see what's going on, and then we'll talk about what to write. What it was? Getting a cube with 3 roots, hopefully. Okay. As you know, cubes sometimes have nice clean roots and sometimes not so clean roots. In this case, it's looking pretty ugly. I just made it up randomly, so I got it to come out very clean. So I want to find the area enclosed by the curve in the x-axis. So that would be the total of that little area and that area. Do I want, though, to just throw one definite integral at it, or do I need to use the absolute value to make all area positive? It's positive, okay? It doesn't say evaluate the integral. In that, if it just said do this problem, then okay, I just throw out the integral and no problem. If it's negative, I don't care. Sometimes you want negatives, but if it says area, then it should be take steps to make total area found. So we're going to do that by using absolute value. In terms of writing, if f of x has been defined previously for you, then you feel free to use f of x, the name for it. You don't have to rewrite the whole thing. That's a waste of your time. What do we need to find? What am I missing in that definite integral? That makes it a definite integral, not an indefinite integral. Yeah, the limits of integration. That's just an antiderivative right now. I need a definite integral. I need limits. What do I do? What do I need to find? I heard zeros. All of them? 2 of them. Which 2? The first and the last. Why isn't that one necessary? Yeah, because the absolute value is going to move that area up. It's just going to be about from the starting point to the ending point, and we're good. So find the first and last. Zeros by analyze graph zeros. Will it find them both for me at the same time? Is there a way to find them both at the same time? Anybody? No? Hey, that would be cool, huh? It feels like it should be able to do that, but whatever. Guess it's not as magical as I thought. All right. Now, pause for a second. This is going to be a pretty common AP free response question, and this will be part A. And over again, you're going to need those bounds. So it's probably good practice to start storing those. To store those, remember you just highlight it and then control store to whatever. The minute it's been stored properly, it'll be highlighted so as to inform you, hey, it's cool, it's there now. Okay? If you're not sure at any point, if you hover over that, it'll tell you, hey, that's A. If you have tons of different points, it might be important to know what's stored where. Okay, do you have that same point, negative 0.348? All right, do the same for the far right point, please. Oh, shoot. Would you store that second point to something? I'm going to just call it B. 0.744. Did you get those same x-intercepts? All right then. So let's express our definite integral, or finish expressing our definite integral. The lower limit is negative 0.348. Now, mine is stored perfectly, exactly, or at least as exact as the calculator can find. But you need to report 3, okay, even in your work. Don't make the misconception that on the AP test, your final answer has to be accurate to 3. That's not the case. Everything they check must be accurate to 3. And so that includes limits of integration and the final answer. So always give me 3 everywhere. What was this again? 2 point? I remember some 4s in there. 4.744. Okay. With that then, you are ready to evaluate the integral. I would probably go back to my home screen. Shift plus. The limits I have are from A to B. I throw in some absolute value, and I plug in the function, which I have as f1 of x. Don't forget the dx, maybe. Do you get something like 36.4406? Yes? Okay then. 33.466. It's sometimes the case, for a reason they want to see if you understand the idea in a different way. Sometimes a multiple choice question might be, what expression is this equivalent to? And you might have as an answer choice 2 integrals. So if I asked you to give an expression of 2 integrals that would find the total area, what would we? Is it what? Did I do something? What did I write? Oh, I sure did. Sorry. Yes, thank you. Good job. Now we're on track. 4. What the heck is all these wrongness? Is that right?
Yeah.
Okay. Told you last one. All right. So, how would you do this in 2 integrals? What 2 integrals would this be equivalent to, or what will I need to do before I can answer that question? Yeah, I'll need to find that other 0. So go ahead and do that. Oh, make sure you can store that. Positives. Okay, so I'm ready to answer this. Tell me my integrals. One integral will be what? From negative 0.3482, 0.604. What function? F of x or negative f of x? That region is positive, yes? So do I need to negate it or just leave it f? Just leave it f. Okay, so that'll be f of x dx. But the next region is negative, so I will take the opposite. You could either say minus this integral or plus the negative of f of x, whichever you prefer. What are the limits of integration? 0.604, pick up from where we left off and go up to 4.744 of f. And again, you need a negative in there somewhere, either out front or inside. Okay? But not too many. Does that make sense? All right then. Let's go to without a calculator. One where you know what the graph looks like, one you don't, which is the hardest. So, if I say find the area enclosed by the x-axis and this cubic, then I would start, if you know the graph, I would start by graphing. So you know where the flip is. The zeros are 0, 1, and -2. Okay. Too close to the edge. -2, 0, and 1. And with positive cube graph knowledge, I'm thinking about that graph, right? All right. Now, because it's not calculator active, we need to actually do this long style. I'm going to say this is equivalent to x times x squared plus x minus 2, or x cubed plus x squared minus 2x. Be a little easier to integrate if it's distributed out. Okay? So, give me my two integrals, please. -2 to 0 of straight up f or negated f? Straight up f. X cubed plus x squared minus 2x dx. And then another integral from 0 to 1 and a negative. Now, do you want to put that negative out front or negate all the terms? Okay, out front. Sounds good. All right, then we have the setup. Now comes the tedium. Now, I'm not a big fan of tedium, but this is part of calculus. And this used to be all calculus. I mean, we didn't have things that could do that for us, so we just did the crap load of these. But you do need practice on it. So I'm going to make you gut it out. What's the antiderivative? 1/4 x to the 4th. 1/3 x cubed minus x squared from -2 to 0 minus same antiderivative. Okay, at least I gave you some fairly friendly numbers. So, in a very clean, organized way, we're going to plug in 0 and then subtract -2. So that would be 0 aplenty minus, notice the parentheses, please. You need to subtract the whole quantity when you put -2 in. So that would be something like 16/4. Actually, you do this and I will do this. We'll compare and see if we can all get through this without making error. This isn't too bad, actually. What'd you get? I'll let you catch up to the old man. Are you getting 7/3? Darn it! Well, this is 1/4 is what you're saying. Yeah. Well then, good job thinking critically, attaboy. Okay, so 1/3, I have 8/3 plus 1. So something like 8/3 minus 7, 7/3 minus 1/4 plus 1, which would be what, 28/12 minus 3/12 plus 12/12 is 25, 37/12. Hi, do you agree? 37/12, what do you think?
I think you're pretty cool.
A little bit of a math bump, so I like it. Okay. Can I get an amen on 3712, or no, I disagree? Yes? Sarah says yes. How about you? Luke? Boyd? You didn't get that? Oh, Boyd, you good? Okay. I'm saying yes. That's you. So this, we're going to do a lot of these. So maybe let's talk about what's the cleanest, what's that? All right, so I fight the temptation to do much combining within because I want to look for like terms. So I got the 7/3 by combining the 8/3 and the 1/3. And I do a lot of combining like terms before I get a common denominator at the very end. I get the common denominator work I do at the very end. Okay? Things will tend to go smaller if you do that. All right. Now then, that's the best cases. You know the graph. You're kind of familiar with what to do. The harder ones are where you are, what I think of as flying blind. You're just kind of trusting your calculus. And you have to do things very carefully because you don't have that visual to check everything with. So imagine if I asked you to find the area enclosed by that graph. Okay? So I guess I could make a table and try and graph it, but it's really not necessary. To do this problem when the graph is not known, what do you reckon we're going to have to do? Why do I graph? So I can figure out where the zeros are. Okay, so the first thing you want to do is find the zeros. Okay, we're going to find the zeros. So if I find the zeros of 3x to the half minus 2x to the 3 halves equals 0, what would you do? Take out an x to the half, yeah. If you factor out a greatest common factor, take out an x to the half. This then becomes 3 minus 2. If you take an x to the half out of x to the 3 halves, what's left? X. Okay. Now, if you're not sure, or if you're iffy, think, okay, wait a second, if I multiplied that back together, would I be good? And yeah, if I distributed that, I would be right back to where I started. So it feels like that factoring is correct, yeah? If I solve this then, surely it's either square root of x equals 0, or 3 minus 2x equals 0, which means that x equals 0 or x equal 2/3 or 3 halves? 3 halves are the zeros. What about domain? This is the square root of x, yeah? So what's the domain? Oh, it's on 0 to 4. They already told me. Never mind. Okay, so great. I found the zeros, so I know it's at the x-axis at those two places. Now what? Yeah, you do. Why do you need to do a sign test? You're absolutely right. Sign test. To see what to negate. Yeah, what needs to be negated. Okay, so if I go from 0 to 3 halves to 4, then 1's a nice number in here. I think you'll agree that's between 0 and 3 halves. At 1, is this positive or negative? Positive, yeah? And after, maybe at 2, or 4, I guess. I guess you could go to 4 because it square roots nicely. But you would get a negative there. I think you'll see if you get into the problem. So, what are my integral setups then? From 0 to 3 halves, leave it or negate it? Leave it. 3x to the half minus 2x to the 3 halves dx, and then negate from 3 halves to 4. All right, now we're rolling. Let's integrate, just for fun. What's the antiderivative of 3x to the half? 3 times, what do I raise it to? I heard 9 halves, so I get to see where you're coming from. x to the 3 halves. When I raise it a power, do I multiply by the new or divide by the new? Divide by the new, so that's times the reciprocal of 3 halves, so 2/3. Minus 2 times x will raise to the 5 halves, and then I multiply by 2/5. From 0 to 3 halves minus. And then thankfully this is going to be the same antiderivative, so 2x to the 3 halves minus 4/5 x to the 5 halves. From 3 halves to 4. Tracking? 3 halves. Whew, this is going to be just hideous, but that's all right. We'll just leave it hideous and call it good. I made this up kind of on the fly, so it probably won't come out right. All right. So at the upper, it would be what? 2 times 3 halves to the 3 halves. That's 3 halves square rooted and cubed. Now that's not pretty. I think I'll just probably leave it like that. Minus 4/5 times 3 halves to the 5 halves. That also is ugly. That whole quantity in parentheses minus, actually the first set of parentheses are crucial. It's the second set where the negative is out front that you need to be careful. So at 0, never mind, it's 0. Minus, and then at 4, 2 times 4 to the 3 halves minus 4/5 times 4 to the 5 halves minus 2 times 3 halves to the 3 halves minus 4/5 times 3 halves to the 5 halves. And let's just call it good, shall we? Okay. If I had done a better job, I would have chosen an interior point that square roots nicely, like 4th or something like that. But I didn't. All right. We'll practice this quite a bit tomorrow. Are you feeling like you have a kind of a clue? Okay. 5, 6, 7, and 8 are on tonight's homework, and they should go okay. But in the interest of catching up, let's try and get 2 homeworks done. Yay! Do you have 57 and 58? Lee? Okay, 57. Questions?
5.
5, did you say?
Yes.
Okay. 1. 57, 5, and 1. Exchanging glances, wandering in the what were the chances? All right, then, let's start there. 57.5. Tell me, was the problem getting the equation? Did you get the equation for volume? This is 0.3. 0.3. They're throwing you a bone by making it a square. They're cutting out corners. I know it's drawn from perspective, so that's why it doesn't look like a square. But if you were to cut out corners of x by x and fold them up, then this base would become the base of the box. Okay, so what's your volume equation, please? 0.3 minus 2x. Say again. Squared, I agree, because that's base and height of the rectangle times x. Sounds good. What are you trying to maximize? You're trying to maximize that, right? So volume must go, or V prime rather, the change in volume must go positive to negative to find a mass. So now I need to find V prime. So this is up to you in terms of technique. Do you want to distribute it out or just product rule that up? Product rule, chain rule. Product rule, chain rule it is. I have great faith in your technique and your skills now. I'll pay you the compliment of assuming you can do this derivative with product and chain without messing it up. Because it is, if you can do it, a lot less work than distributing. So, product rule, first stays the same. Derivative of the second plus second stays the same. Derivative of the first. Now what's the derivative of that square term? Derivative of the outside? 2 comes down. Drop it to 1 times the derivative of the inside, which is -2. Okay? Now in terms of solving this in its cleanest possible state, I'd strongly recommend you take that out. There's a greatest common factor of 0.3 minus 2x. When you take that out of this guy, what's left is still a single 0.3 minus 2x. And when you take it out of this guy, what's left is x2 and -2, or -4x, right? Okay then, so in terms of zeros, I'll either get a solution of 0.3 minus 2x equals 0, or 0.3 minus 6x equals 0. This would be x equals 0.3 over 2, or 0.15. And this would be 0.3 over 6. That's kind of weirding me out. That's 3 over 60, or 1/20th. 0.05 if you like. I don't care, whichever you prefer. Now, I could do a sign test on this, and it's fine. I would say this. What's the shape of this? Positive x cubed or negative x cubed? It's positive because it's square root of positive x cubed. It's shaped like this. So will the max be at the lesser critical number or the greater critical number? The lower critical number, the first x where the derivative is 0 is going to be the max. So which of those is the max? 0.15 or 0.5? Or 0.05. And if you did a sign test, you'd see that. So this is the max. Then make sure you answer the question, do they want the dimensions or do they want the max volume? They say, find the size of the square that can be cut out and what's the max volume. So you would, when we found x, that's the size of the square. So we would say, hey, person making this, cut out a square of 0.05 by 0.05. The max volume is going to have to be, pick up your calculator time. Where should I go to find the best possible volume? Yeah, go to this equation here. Volume at 0.05 is 0.3 minus 2, 0.05 squared times 0.05. Whatever that is, 0.3 minus 0.1 squared is 0.05. That's 0.2 squared times 0.05. You get 0.4. You probably picked up your calculator 20 minutes ago, but that's fine. 20, 1, 2, 3, 4, 1, 2, 3, 4. I'm thinking the max volume is 2,000. Okay. That's interesting. Okay. All right, question on 1. Is that still a question? All right. So you've got this figure here, and you're given an x-intercept of 6, 0, 6, and a y-intercept of 0, 6, and an x-intercept of 4, 0, and xy could be any point on that line, so that the rectangle could be this guy, or this guy, or this guy, or this guy. All these different possible black rectangles, but there's a best rectangle in terms of area. What is it? So this is an optimization problem. You start by saying you're trying to maximize the area. You get an equation for that. It would be the x times the y. Now you always want to get it down to 2 variables, so you look for another substitution fact. to get to two variables. What's another relationship between x and y? Bless you. No matter what this x and y is, it's always on the line. So the line is the xy relationship. They're related by being on the line. So give me the equation of that line. Let's go slope-intercept form this time. What's the slope? Three halves, positive or negative? Negative 3/2, down 6 over 4. What's the y-intercept? 6. Okay, so great, I have this line. What do I do with it? Hi. What do I do with this line now? I plug it in for y so that I can get an equation I can maximize. Thank you. Have a good day. X times negative 3/2 x plus 6. Normally I'd use product rule, but this is just as easy to distribute. Negative 3/2 x squared plus 6x. Great. Now what? Find where? What goes positive to negative? Or the derivative. A prime goes positive to negative. Am I taking the derivative with respect to time or x? X. Yeah, there's no time component. I'm saying as I change x, how does the area change? So it's change in area with respect to changes in x, dA dx. So that's negative 3x plus 6. Doesn't get much nicer than that for an equation to solve. X is 2. Does A prime go positive to negative around 2? At 1, is this positive or negative? Positive. And then at 5, negative. So is that a max I just found? Yeah. Okay. So answer the question, and you should be good. Question says, find the coordinates of the point that maximizes the area. So to answer the question, I would say x equals 2. I'd also need the y equals 3, yeah. Okay. Other questions on 57? Super, 58 we go. Questions on 58? 2 on the back. 2 on the back. Oh, you probably need, yeah, that'll probably take the whole period. So let's just go there. We might not get through it. That's okay. So this is going to start, we've practiced this a little, but this is going to take a different turn pretty soon. I want you to get practice on 58. Oh man, I didn't get any inverse trig practice on your homework. Inverse sine of root 3 over 2. Go. Pi over 3 is correct. Did somebody say pi over 11? What's that about? All right. So, packages arrive at a UPS sorting facility rate of blah, blah, blah. So a periodic rate, they come in from planes, and so they do come in spurts. 750 packages per hour. The workers process at a rate of 750 packages per hour. Right away, you can see that this is done in real life. Okay, you model. This is what a math person who does this is called an operations researcher. All right, so it's mom and pop shop's not going to hire a mathematician and analyze their business. But if UPS hires me and I can shave off 1 second per person, I just save them hundreds of millions of dollars. Hundreds of millions. And so my $1 million salary, boom, paid for. So if you want to be a math person besides a math teacher, operations research, maybe. So at any rate, I'm going with a very simplistic version. A person doesn't work there constantly. That's just not how it works. They get tired. They get better as time goes on for a while. And so there's a huge assumption this is a form. But for our purposes, it'll work. All right? Now, packages are coming in at this rate and out at that rate. And so you could think of a net rate as the change in the number of packages with time. And it's kind of like a derivative because it's a rate of change, right? So how would you put the two rates together to get a net rate of change? Which, really think of it as what adds to the number of packages and what subtracts from the number of packages. Packages arrive at this rate. Will that increase the number of packages or decrease? Increase, okay, they're arriving, so I'm getting more packages. So should that be positive or negative? Positive, okay. Now I'm processing the packages. In other words, they come in on a conveyor belt from an airplane, and I put them onto trucks to this region or that region. So I'm getting them out of the facility at this rate. So is that increasing or decreasing the number of packages? Decreasing. So give me a net rate. P of t minus R of t. Now, you could definitely leave it like that, but in terms of getting a simple thing to put into my calculator, if I took this, take away that, the sign expression would just stay the same, but 1,000 minus 750 is 250. Plus 420 sine of pi over 5t minus 2. Okay? I don't want to put that on a separate line. So, question, just looking at it, knowing your sign knowledge, will this ever be negative? What's the 250? What's the 420? What's the 250 graphically on this curve? It's the center line. It's the center line. Instead of doing this, yeah. What about the 420? What does it do? It's the amplitude, okay? So this is going to go 250 up to 420, so the most I'll ever get is a rate of 670, and down to some negative number, right? Okay. So without even looking at this in the calculator, I kind of know it's going to be a sinusoid crossing over the x-axis. This is calculator active, however. I think I told you that somewhere. Did I? Yeah. Okay. So you may use a calculator. Oh, yeah, right there. Sorry, good point. So you may use a calculator, and we're not going to have time to get through this. But does it look like this, Sarah? You did this, right? Yeah. Okay. So if you look something like that, when is the number of packages increasing, given that this is the rate of change? It's increasing if the rate of change is positive. So that's when dm dt is positive or above the x-axis on some interval. And that's my y. I'm getting that y, and I'm not making the calculations because I don't have time to put this in my calculator. That might get you started, but we'll finish going over it tomorrow. All right? Keep 58 if you need to. 57 is due. Have a nice day.